Welcome back to Statistics. Before I start today's lecture, I will review the topic in the last lecture. First, I asked the question, what is the standard deviation good for? I covered three answers to this question. First, the standard deviation is the average distance of the scores from their own mean. There are three steps to calculate the standard deviation. The first and third steps sort of cancel each out. So what you are left with is an average, the average distance of the scores from their mean. Second, the standard deviation is a measure of the spread or variability in a distribution. These three normal distributions have the same mean and the same area. However, they have different standard deviations. Their spread from side to side is different. If the distribution is wider, then the standard deviation is larger. Third, the standard deviation is a yardstick that we can use to measure how much an individual differs from the average. This is probably the most important use of the standard deviation. This is where we come to G-scores. G-scores are based on the idea of using the standard deviation as a yardstick. G-scores and the standard deviation are two of the most important ideas in this course. If you want to do well in the rest of this course, you need to really understand G concept. You need to read the relevant chapters. A G-score indicates how far an individual is from the mean using the standard deviation as a yardstick. And the G-score indicates whether the individual is above or below the mean. A positive G-score indicates the individual's raw score is above the mean. A negative G-score indicates the individual's raw score is below the mean. It's easy to calculate a G-score. As it shows, an individual's G-score is simply their deviation from the mean divided by the standard deviation. At the end of the last class, you practiced calculating deviations and turning them into G-scores. Now, we are about to cover some new topics. They are all about what statistics call transformations. A transformation is turning one kind of score into another kind of score. As a first example, let's talk about turning raw scores into G-scores. This is what we call the basic formula for G-scores. It's the same formula you learned during the last lecture. G-score is equal to the deviation of the raw score divided by the standard deviation. Here is the new formula for the G-score. This new formula on the bottom is the same as the basic formula on the top. The only difference is in the bottom formula, we have substituted the expression raw score minus the mean in the place of the word deviation. We can make this substitution because the deviation is equal to the raw score minus the mean. So really, these formulas are saying exactly the same thing. Both formulas are useful. The formula at the top, the basic formula, is very important because it shows the underlying idea of the G-score. The underlying idea of the G-score is this. It shows how far someone's raw score deviates from the mean using the standard deviation as a yardstick. The formula at the bottom is useful because it shows how you can take a raw score and turn it into a G-score. I will give you an example. Let's say a student gets a raw score of 16 at the test. And let's say the mean of the class on the test is 10. And the standard deviation is 2. So here's the question. What is the student's G-score? To solve this question, we will use the formula where we take a raw score and turn it into a G-score. So here is the formula. We can use this to take a raw score and turn it into a G-score. First, we plug all numbers into the formula. His raw score is 16, so that we plug it into the formula as a raw score. The mean of the class is 10, so we plug that into the formula as the mean. and the standard deviation of the class is 2, so we plug that into the formula. So to find the g-score, we first subtract 16 minus 10, and then we divide by 2. 16 minus 10 is 6, so the g is equal to 6 divided by 2. 6 divided by 2 is equal to 3, so g-score is equal to 3. That's our answer. The g-score for the student is 3. How many standard deviation is the students above the mean? Okay, so the student is 2 standard deviations above the mean. When we use this formula to take a raw score and turn it into g-score, we would say we are making a transformation. A transformation is taking one kind of score and turning it into another kind of score. So taking a raw score and turning it into a g-score is a transformation. Now, I will show you another kind of transformations. How to take a g-score and turn it into a raw score. I've just been showing how to take a raw score and turn it into a g-score. So now I'm going to explain how to do the reverse of that. How to take a g-score and turn it into a raw score. This formula allows you to take an individual g-score and turn it into a raw score. The formula says that you multiply the g-score times the standard deviation to get their product. Then you add this product to the mean to get the raw score. Okay, here is the example. Let's say another student takes the same spelling test that the previous students took. Her g-score is 2.5. As you remember, the mean for the whole class is 10 and the standard deviation is 2. So here's the question. What is her raw score? This is how many did she get correct on the test. So here's the formula. It allows us to take a g-score and turn it into a raw score. To find the raw score, we first multiply the g-score times the standard deviation, and then we add the mean. We just plug the numbers into the formula. It says the g-score is 2.5, so we plug that score into the formula. It says that the standard deviation is 2.5, so we plug that into the formula. And lastly, the mean is 10, so we plug it in. Next, we multiply 2.5 times 2, so that's 5. Finally, we add 5 plus 10, and that's equal to 15. 15 is the student's raw score. This is the formula we've just been using. You can use this to take a g-score and turn it into a raw score. It's a good idea to memorize this formula. So I'm going to show you a little trick to remember this formula in case you forget. This is a different formula. What is this formula? This is what we are calling the basic formula for a g-score. The g-score is equal to the deviation divided by the standard deviation. Now, I'm going to show you the trick I mentioned. You can take the basic formula here and use a little simple algebra to find the formula that allows you to take a g-scores and turn it into a raw score. Let me show you the algebra. First, you multiply both sides by the standard deviation. When you multiply the left side by the standard deviation, you get the g times the standard deviation. When you multiply the right side times the standard deviation, this cancels out the standard deviation in the denominator, and you get the deviation. Okay, next we make a substitution. The deviation is equal to the raw score minus the mean. So we substitute the raw score minus the mean into the formula. Finally, we add the mean to the both sides. On the left side of the equation, we just add the mean. On the right side, we also add the mean. But when we add the mean to the right side, we get the raw score minus the mean plus the mean. That plus mean and the minus mean cancel each other out. So we are left with the raw score. So this formula on the bottom is the one that I showed you a minute ago. That takes a g-score and turns it into a raw score. If you forget this formula at the bottom, you can just remember the basic formula for the g-score. G-score is equal to the deviation divided by the standard deviation. If you remember this formula at the top, you can always use a little simple algebra to find the formula at the bottom. This formula we've been talking about, which takes a g-score and turns it into a raw score, is a transformation. We are now going to talk about how to do some other transformations. Next, we are going to discuss how to take a g-score and turn it into a percentile. We will also show you how to do the opposite. To understand how to do this, you must first understand the relationship of g-scores to percentiles of the normal distribution. To change g-scores to percentiles and vice versa, you need to memorize these 5 numbers. This course does not involve much memorization of numbers and formula. However, these 5 numbers are really important and you will need to memorize them too. So now I'm going to show you where these numbers come from and why they are important. So this is a normal density distribution, and we are going to fill in the scale for the g-scores at the bottom. The mean always have a g-score of 0. So the g-score of 0 is right here in the middle. A g-score of 3 is the right end, and a g-score of negative 3 is at the left end. So now it's easy to fill in the rest. So a g-score of 1 is 1/3 of the way between 0 and 3, and the g-score of 2 is about 2/3 of the way between 0 and 3. Similarly, a g-score of -1 is 1/3 of the way between 0 and -3, and the g-score of the -2 is about 2/3 of the way between 0 and -3. Now, anytime you see a normal curve, you can fill in the scale for g-scores at the bottom in the same way. Okay, now we are going to create a second scale at the bottom. And this second scale is for percentiles. Remember, a percentile indicates the percentage of individuals who score lower than a particular score. So if a student scores at the 30th percentile on the IQ test, that means that the 30% of individuals have IQ scores lower than his. But if he scores at the 80th percentile, then that means the 80% of individuals have IQ scores lower than his. Okay, now I'm going to ask a question. On this histogram, what percentile should be written here underneath our g-score of 0? Or another way to ask, what percentage of individuals have a g-score less than 0? The correct answer is 50%. Here's the way to get the answer. We know that a g-score of 0 is always equivalent to the mean. We also know that the normal distribution is symmetric. And in a symmetric distribution, the mean and medians are always the same. So a g-score of 0 is equivalent to both the mean and the median. But the median is defined as the 50th percentile. In other words, 50% of individuals fall below the median. So in the normal curve, a g-score of 0 is equivalent to the percentile of 50. In another way to say, a g-score of 0 is at the 50th percentile. And this is true for all normal distributions. In all normal distributions, a g-score of 0 is equivalent to the mean, the median, and the 50th percentile. Now, I filled in the percentiles for most of the g-scores here. Let's start on the left. A g-score of -2 is equivalent to a percentile of 2.5%. This means that in a normal distribution, only 2.5% of individuals have a g-score less than -2. And we can see that on this histogram, which is a density distribution. We can see that only a little tiny bit of the histogram's area lies to the left of the g-score of negative 2. In fact, the area to the left of negative 2 is 2.5%. Similarly, a g-score of negative 1 is equivalent to a percentile of 16%. That means that 16% of individuals have a g-score less than negative 1. We already know that a g-score of 0 is equivalent to the 50th percentile. A g-score of 1 is equivalent to the 84th percentile, and a g-score of 2 is equivalent to a percentile of 97.5%. Alright, so now here is a question for you. What percent of individuals have a g-score greater than 1? Okay, so what percentage of individuals have a g-score higher than 1? Alright, so we can see from the percentiles that the 84% of individuals have a g-score less than 1. So that means that the remaining 16% of individuals must have a g-score greater than 1. And notice that the 16% is already in the graph here on the left. The graph shows that 16% of individuals have a g-score less than negative 1, and another 16% of individuals have a g-score greater than 1. The graph is symmetric, so we can get the nice matching. 16% of individuals are less than negative 1, and 16% of them are more than 1. Alright, now again, I'm going to ask a question. What percentage of individuals have a g-score greater than 2? Alright, so you see the pattern. If 97.5% have a g-score less than 2, then the remaining 2.5% must have a g-score less than negative 2. And we can see that the 2.5% is here in the graph already because the distribution is symmetric. 2.5 of individuals have a g-score less than negative 2. These percentiles on the graphs are the ones I showed you earlier and say that you need to memorize. So as you can see, these percentiles are really important because they're equivalent to the g-scores of negative 2, negative 1, and so on up to 2. And it's very useful to memorize these percentiles because if you're given almost any g-score, you can use these numbers to make a good guess and estimate of what the equivalent percentile is, and vice versa. Let me show you what I mean. Now, this histogram doesn't give the exact percentile for our g-score of 1.5, but you can estimate the percentile using these numbers that are here at the bottom. If an individual has a g-score of 1.5, what would you guess is the equivalent percentile? A g-score of 1.5 lies halfway between a g-score of 1 and a g-score of 2. So we can guess that the equivalent percentile is somewhere around the halfway between 84% and 97.5%. Maybe around 91%, maybe around 90 or 92%. We are not trying to get the exact answer, just make a good guess. Next, I will show you how we can use these numbers for another purpose. In a normal distribution, what percent of the individuals have scores within one standard deviation of the mean? Let me explain what I mean by within one standard deviation. Let's say you want to know how many restaurants and bars there are on the mesa within 1 mile of Whataburger. To find the answer, you find the spot on the mesa that is 1 mile north of the Whataburger and the spot on the mesa that is 1 mile south of the Whataburger. And then you can count all the restaurants and bars between these two spots. In the same way, when I ask you what percentage of individuals have scores within one standard deviation of the mean, I need to find a spot on the graph that is one standard deviation above the mean, and the spot on the graph that is one standard deviation below the mean, and then calculate the percentage of individuals who are between these two spots. So you can calculate this percentage from this histogram. We know that 84% of individuals have scores less than 1, and 16% have z-scores less than -1. So the area of the red area is 84% minus 16%, which is 69%. Okay, so if you have a question, please email your instructor. Here is a similar question. What percentage of individuals have scores within 2 standard deviations of the mean? Here is the histogram will help you answer this question. What is the area of the histogram for scores within 2 standard deviations of the mean? We know that the percentage of individuals with z-score less than 2 is 97.5%, and the percentage with z-score less than -2 is 2.5%. So the red area is 97.5% minus 2.5%, which is 95%. So the percentage of individuals with z-score with 2 standard deviations of the mean is 95%. You should memorize the first two numbers, 68% and 95%. So now we are ready to discuss another transformation, how to take a z-score and turn it into a percentile. After that, we will discuss the reverse of that, how to take a percentile and turn it into a z-score. There are 3 steps involved when you start with a z-score and turn it into a percentile. First, you need to sketch the normal curve and write the z-scores and percentiles at the bottom. Then you use the sketch to make an estimate of the answer. Then you use the table of the percentiles for z-scores to find the exact answer. I am going to show you these 3 steps right now. Now here is the table we will be working with. Your textbook also contains copies you can use. Now I will show you how this table works. The numbers at the edge of the table are z-scores. It's a little more complicated than that, but I will be explaining more in a minute. The numbers in the middle are percentiles. Okay, so now I will show you how to use the table. If you start with the z-score and you need to turn it into a percentile. Here is a question we will use. What percent of people have a z-score below 1.53? The first step is to make a sketch of the normal distribution and fill in the z-scores and percentiles. So this is what you draw to start with. When you sketch it, you don't have to color it in red and blue. The main thing is to draw the curve of the distribution. Then fill in the z-scores and percentiles the way I taught you earlier. For z-scores, fill in 0, then positive and negative 3, then the other z-scores. Under the z-scores, fill in the equivalent percentiles, 2.5%, 16%, 15%. Next, the second step is to estimate the answer you are looking for. The problem gives you a z-score of 1.53, so you mark the point on the graph. It's about halfway between a z-score of 1 and a z-score of 2. You don't have to worry if you are a little off here, because you are only looking for a rough estimate. Now that you have identified the point that represents a z-score of 1.53, you can use the scale at the bottom to find the equivalent percentile. We don't know exactly what the percentile is, but we can see it's about halfway between 84% and 97.5%. So we will guess that the percentile is about 91. So now we have a rough estimate of the answer we are looking for. If a z-score is 1.53, then its percentile is approximately 91. Now we come to the third and final step. we are going to use the table of the standard normal cumulative distribution to calculate the exact answer to the problem. So here is the table. Now we are beginning with a g-score of 1.53 and we are going to find the equivalent percentile using this table. First, we find the first part of the g-scores on the left side of the table. Our g-score is 1.53 and its first part to the 10th place is 1.5. So here on the left of the table I have circled is 1.50. Of course, something is missing. The g-score of 1.53 has 3 in the 100th place. So we find this 3 here at the top of the table. It says 0.03, which is the same as the 300th. Notice that if we add the 1.50 on the left and the 0.03 on the top, we get the g-score we are looking for, which is 1.53. Now we find the percentile equivalent to 1.53. We draw one arrow from 1.5 and another arrow from 0.03. The two arrows meet at the number 0.9370. This is the percentile we are looking for. A g-score of 1.53 is equivalent to a proportion of 0.937, which is the same as a percentile of 93.7%. Now, before we counting, let's check our work using the estimate we made earlier. When we looked at the sketch, what did we estimate the percentile would be? So our estimate was 91%, and the exact number we found in the table is 93.7%. The two numbers are pretty close to each other, so this gives us confidence that we haven't made a huge mistake somewhere. So using the table, we now know a g-score of 1.53 is equivalent to a percentile of 93.7%. This tells us that 93.7% of people have a g-score below 1.53, and that's the answer we are looking for. Here is the problem. On the final exam, Beto scored better than 80% of the students. What was his g-score? As you can see, in this problem, we are given his percentile. What is his percentile? Okay, so Beto scored at the 80th percentile, and now we need to find his equivalent g-score. So again, the first step is to make a sketch of the normal distribution. Here is the normal distribution with the g-scores and percentiles filled in. The next step is to make an estimate of the answer we are looking for. So the problem told us that he scored at the 80th percentile. On the sketch, we marked the point that indicates the 80th percentile. Remember, we are just making an estimate, so we don't have to be super accurate here. Next, we want to estimate the g-score that is equivalent to the 80th percentile. What g-score would you guess is equivalent to the 80th percentile? Alright, so using the sketch, I estimated that a g-score of 0.75 is equivalent to the 80th percentile. But I was just guessing, and your guess may be more accurate than mine. Okay, so we shall see. Now we are ready for the third step, in which we use the table to find the exact answer. Now we are starting with the percentile this time. Remember, the percentiles are in the center of the table. We need to find the percentile in the table that is closest to the percentile in our problem. The percentile in the problem is the 80th percentile. In the table, there is a cell with a percentile of 0.800, so we circle it. Next, we draw two arrows to find the g-score that corresponds to 0.800. One arrow points to the left from 0.800. This arrow points to the number 0.80 on the left edge of the table. So this is the first part of the G-score we are looking for. The other arrow points to the top of the table. This arrow points to the number 0.04. So this is the second part of the G-score we are looking for. When we put the first part of the G-score with the second part, we get the G of 0.84. This is the G-score we are looking for. Using the table, we found that a G-score of 0.84 is equivalent to a percentile of 80. This tells us that Bedel's percentile score of 80 is equivalent to a G-score of 0.84, and this is the answer we are seeking. So we've just learned how to do two kinds of transformations. Taking the G-score and turning it into a percentile is one transformation. And doing the opposite, taking a percentile and turning it into a G-score is also another kind of transformation. Now we are going to learn another kind of transformation, how to take a raw score and turn it into a percentile. We will also see how to do the opposite. This is how to take a percentile and turn it into a raw score. To understand about how to get to raw scores to percentiles or vice versa, I want you to imagine you have to drive from El Paso to Las Cruces on I-10. The only way to get from El Paso to Las Cruces is through Anthony. There isn't any other way. Something similar is true if you want to go from a raw score to a percentile. The only way to get from a raw score to a percentile or from a percentile to a raw score is to go through the G-scores. You always use G-scores when you're converting a raw score to a percentile or vice versa. Luckily, you already know how to do the whole thing. You already know how to go back and forth between raw scores and G-scores, so you just need to use the formulas. And you already know how to go back and forth between G-scores and percentiles as well. So you just need to use the table of the percentiles of G-scores that we've used a few minutes ago. So if you want to go from raw scores to percentiles or to percentile to raw scores, the first and the most important secret is to always change to the G-scores. If you have a raw score, you can change it to a G-score using the formula you've learned. If you have a percentile, you can change it to a G-score using the table. The second secret is to make a sketch and estimate. It really helps to do this. So I will give you an example of how to do this. Here is a problem that involves Bedel again. On the final exam, the mean was 70 and the standard deviation was 10. Bedel scores better than 80% of the students. What was Bedel's exam score? So this problem gives us a percentile. Bedel was at the 80th percentile, and it asks what his raw score on the exam was. We are starting with a percentile and we want to end with a raw score. We know that to go from a percentile to a raw score, we have to pass through G-scores in between. It's like if we go from El Paso to Las Cruces, we have to pass through Anthony in between. Let's go ahead and convert the percentile to a G-score. Bedel scores better than 80% of students. That tells us his score is at the 80th percentile. Now, how will we find the G-score that is equivalent to the 80th percentile? Normally, we would have to use a table to find the G-score that is equivalent to the 80th percentile. However, we already did that in the last example for Bedel, and we found that his percentile of 80 is equivalent to a G-score of 0.84. So we don't have to use the table right now, but usually we have to if we want to go back and forth between percentiles and z-scores. Now that we know the z-score is 0.84, so we can calculate the raw score. So here's the normal distribution again, with the z-scores and percentiles. However, this time we are also using raw scores, so let's add a scale for raw scores. So what raw score should we write here under our z-score of 0 and the percentile of 50? A z-score of 0 is always equivalent to the mean of the raw scores. Here at the bottom, we see that the mean of the raw scores is 70, so we will write that in. And what do we write here under the z-score of 1 and the percentile of 84? Well, the z-score is 1. That means the raw score is 1 standard deviation more than the mean. The standard deviation is 10, so a z-score of 1 is equivalent to 10 more than the mean. So the 10 more than 70 is 80. And what do we write here under the z-score of 2? A z-score of 2 indicates the raw score is 2 standard deviations above the mean. So the raw score that is 20 above the mean is 90. In the same way, we can fill in all the raw scores. So we now have 3 equivalent scales, z-scores, percentiles, and raw scores. Notice how easy it is to fill in the raw scores. The mean raw score is always equivalent to a z-score of 0. You add 1 standard deviation to the mean to get the raw score that is equivalent to our z-score of 1. You add 1 standard deviation to that to get the raw score that is equivalent to your z-score of 2. You then can subtract the standard deviation from the mean to get the raw score that is equivalent to the z-score of -1. And then you subtract 1 standard deviation from that to get the raw score that is equivalent to our z-score of -2. Now, we already know Beto is at the 80th percentile. We also know that the 80th percentile is equivalent to our z-score of 0.84. And by looking at the scale of raw score we added to the histogram, we can see the equivalent raw score is approximately equal to 78. So that's our estimate. We expect Beto's raw score to be close to 78. So now we have an estimate of Beto's raw score, but now we want to calculate the exact value. We know we will change to z-scores, and because we are going back and forth between z-scores and raw scores, we will be using a formula. Here at the top, we have Beto's z-scores of 0.84. And below, we have the mean and standard deviation of the raw scores. The question now is, what is Beto's raw score? What is a raw score that is equivalent to a z-score of 0.84? As we learned at the beginning of this lecture, there is a formula for calculating a raw score from the z-score. Here is the formula. To calculate the raw score, we multiply the z-score times the standard deviation, then we add the mean. We just have to plug the numbers at the top of the slide into the formula. Here the calculation. At the bottom we can see the answer is 78.4. So we conclude that the Beto scored at the 80th percentile, which is equivalent to a raw score of 78.4. Based on our sketch, we estimated the raw score to be 78. Our estimate of 78 is very close to the exact value of 78.4. So that increases our confidence that we didn't make any mistakes and that 78.4 is the correct answer. Just a reminder, taking a raw score and turning it into a percentile is a transformation. And taking a percentile and turning it into a raw score is also a transformation. Alright, so let's summarize today's lecture. You have learned how to turn raw scores, z-scores, and percentiles into each other. You have also learned how to sketch the normal curve, fill in the z-scores and percentiles, and use the sketch to obtain approximate solutions to the problems.